In this video, we'll talk about another important consideration when building models: interaction. Consider a model of annual wages based on a person's education level in years and their job industry. Within this model, let's focus on the education coefficient. When controlling for job industry, that is, within any job industry, annual wages increase by an average of $4,734 for every extra year of formal education. By assuming this rate of increase is the same within each industry, our model is represented by 6 parallel lines, one for each industry. For example, within the construction industry, represented by the top line here, we expect wages to increase by an average of $4,734 for every extra year of education. Similarly, within the service industry, represented by the bottom line here, we expect wages to increase by an average of $4,734 for every extra year of education. But something doesn't seem right about that particular conclusion. Though our model assumes that the benefits of more education are the same in every job industry, experience suggests that advanced educational training is more important to some industries than others. In fact, our data agrees that wages rise faster with education in some industries than in others. For example, it seems that more education literally pays off more in the management sector, which has a steeper slope, than in the transportation sector, which has a less steep slope. This plot provides some evidence of interaction. In general, let y be a response variable and x1 and x2 be two predictors. Our previous multivariate models have assumed that the relationship between y and our predictor x1 is independent of or completely unrelated to the other predictor x2. In contrast, if the relationship between y and x1 differs depending upon the values or categories of x2, we say that our two predictors interact. For example, the relationship between wages and education differs depending upon the job industry. Thus, our education and job industry predictors interact. Luckily, we can fix our model to reflect this interaction. Recall that when our predictors x1 and x2 do not interact, we can model y by beta 0 plus beta 1 x1 plus beta 2 x2. And if x1 and x2 do interact, then we can incorporate an interaction term into our model. Mathematically, the interaction term is the product of the predictors. Thus, our model of y is represented by beta 0 plus beta 1 x1 plus beta 2 x2 plus our final term, beta 3 times the product of our two predictors, x1 and x2. This last piece is the interaction term. For example, let's model wages by education and job industry with an interaction term. For simplicity, we'll examine just the management and transportation sectors. Now, once we build this model, we can use it much the same as our more familiar models. First, let's write out our model formula. To this end, we can write down the estimate column for the estimated model coefficients. Thus, wage equals negative 65,591 plus 8,678 times education plus 90,232 times transportation minus 7,580 times the product of education and transportation. To get a handle on this formula, let's use it to make some predictions. First, let's predict the wage for somebody with 15 years of education that works in management. To this end, we can plug in 15 in both the education predictor and where it appears in the interaction term. Similarly, since we're interested in the management sector, not the transportation sector, we can plug in 0 for both the transportation predictor and where it appears in the interaction product. Effectively then, since they're multiplied by 0, these last two pieces of our calculation drop out, and we have a predicted wage of $64,583.50. This prediction is consistent with the height of the management line when education is 15. Thus, we have some graphical proof that we're on the right track. Next, let's predict the wage for somebody with 15 years of education, but that works in transportation. In this case, we can again plug in 15 for both the interaction predictor and where it appears in the interaction product. Similarly, since we're interested in the transportation sector, we can plug in 1 for transportation here, where the transportation predictor is and where it appears in the interaction term. Combining these 4 different pieces then, we have a predicted wage of $41,112.31. This is lower than what the predicted wage was for a person in management with the same level of education. Further, this prediction is consistent with the height of the transportation line when education is 15. Finally, let's use our model formula to reason out the equation for the 2 industry lines shown here. Starting with the management sector, we can set the transportation term to 0. Thus, these last 2 pieces that involve transportation drop out of our model, leaving us with the equation for the management line. It's negative 65,590.6 plus 8,678.3 times education. Now we have to be a bit more cautious in obtaining the equation for the transportation line. In this case, we set the transportation term to 1, both for the transportation predictor and where it appears in the interaction term. So notice then that we have 2 constants, negative 65,591 and 90,232. And we can combine these like terms into a single constant. Similarly, we have 2 education terms, 8,678 times education and negative 7,580 times education. And again, we can combine these like terms. So, plugging these values into our calculator, we get out the equation that wages equals 24,642 plus 1,098 times education. Stepping back now and remembering the bigger picture, including the interaction term produced the equations here for the relationships between wages and education in the management and transportation sectors. Importantly, not only do these 2 equations have different intercepts, they have different slopes. Comparing the 2, notice that the transportation equation has a higher intercept, thus indicating that the baseline wage starts out higher in the transportation sector, something that we can see in the plot here. So the wages, or the baseline wages / intercept, are starting out higher in transportation than in management. However, the transportation equation has a lower slope. It's 1,098 versus 8,678. This indicates that wages increase more slowly with education than they do in the management sector. Again, we can see this in our plot, that the transportation sector has a lower slope than in management. So in general, wages start out higher in the transportation sector, but grow more slowly. They start to be outpaced by the management sector, starting with education levels around 12 years.